simulator of neural networks integrated in artificial worlds written in Python. The images in this video are from version 0.5, but NeuroCellSim is currently in phase 1.0. In the following videos, you will see footage of the program in 4 previous versions to explain its features as they were implemented, tested, corrected, and improved over several months. The simulator generates an artificial world with certain characteristics and, within it, a set of entities that contain neural networks that collect information from that world, process it, and generates a behavior that allows them to survive or not. Those that manage to survive long enough have the opportunity to reproduce, generating more similar neural networks in the process. In the long run, it is expected that, over the course of several generations, neural networks will be better fitted to the world they perceive, following an artificial selection based on the features of neural networks themselves, their environment, and reproduction. Most of the neural networks used today and during the last decades follow a layered scheme to locate hidden neurons in hidden layers. That is, each neuron is in one layer and can only receive information from neurons belonging to the previous layer and send information to those on the next layer. However, the neural networks used in NeuroCellSim follow a paradigm closer to that of liquid-state machines. In this type of neural network, each hidden neuron can connect to anyone. In any neural network, there are 3 types of neurons, and in NeuroCellSim, they work as it follows. The input neurons receive raw information from the outside. In the case of NeuroCellSim, that information is the distance in 2 coordinates to the nearest food. Input neurons can only have outgoing connections. Hidden neurons, along with their connections, process the information that comes in from the inputs. In NeuroCellSim, they can be connected in any way with almost any other hidden neuron. They can also have incoming connections with input neurons or outgoing connections with output neurons. Output neurons emit information to the outside in the form of behavior. In the case of NeuroCellSim, the distance the cells moves in both coordinates. Output neurons can only have incoming connections. The features of the environment nourish the neural network of information to be processed and a model to which it adapts in its struggle for survival and reproduction. Therefore, the properties of the environment are essential in determining what type of neural configurations will be most successful in the long term. In NeuroCellSim, the environment is quite easy and what the cells are capable of perceiving basic. The simulator is made up of a group of food units that appear randomly in the world and a set of cells with neural networks capable of perceiving the distance only to the nearest food. If the behavior of a cell is to approach and eat, it will be more difficult for it to starve, and if it has enough energy, it will be able to reproduce. Cells that stay away from food or do not move eventually starve to death, or upon reaching a certain age in future versions. However, out of all this, cells are only able to perceive the distance to the nearest food. The environment they can see is very simple. Although throughout the development of NeuroCellSim, the complexity of the environment and the ability of cells to perceive more things or to perform new behaviors will not change, it is expected that a more complex environment will result in the development of more complex neural networks as well. In this version of the simulator, cells don't have any kind of distance limit to their vision. They can see the closest food as far away as it is. In future versions, it will be implemented the option to establish a limit to the distance of their vision. On the other hand, at this point, cells can only reproduce asexually. The generation of the new neural network is carried out as follows. It starts from a copy of the parent neural network, and a series of minor random changes is applied, simulating mutations. These changes can develop in one, several, or none of the following directions. Neurons can be created or destroyed, connections can be created or destroyed, and the synaptic weights of some connections can change. In future videos, I will talk in greater depth about how the reproduction and generation of new neural network works in NeuroCellSim. In addition, in future versions, it will be incorporated the possibility that they can reproduce sexually. Along with the ability to reproduce, cells can also starve if they go without food for a long time. The possibility of making mortal cells dying upon reaching a certain age would be implemented in the last version. In NeuroCellSim, there are two types of food spawn rhythms. It can be random or keep the same amount of food at all times. In the first case, the simulation goes through times when there is a lot of food and little population, or little food and a lot of population. In the second case, the population increases exponentially and food is scarce and does not last long. On the right side of the screen, you can see a graphical representation of the neural network and its connections. Information from the outside enters through the input neurons to the hidden neurons. Between the hidden neurons, the green connections work in a clockwise direction and the red in the opposite direction. Finally, some of the connections go out to the output neurons, generating a behavior. On the other hand, the information that each neuron contains is stored in its state. Finally, when it comes to giving color to each cell, it has been chosen to base its color on three characteristics of its neural network. The number of hidden neurons regulates the amount of red. The amount of green is calculated based on the average percentage of connections out of all possible connections. The amount of blue is based on the total variance of the synaptic weights. In future versions of NeuroCellSim, the methods used to calculate these quantities will vary, so the color gamut of NeuroCellSim cells will also change in future videos. In the next video, I will talk about how these neural networks can learn and adapt to their environments.